In this topic, let's look at VMs, instances, and containers. Now, a database server used to be kind of a substantial process, a heavyweight process, required a significant amount of resources to set up and configure and run, and a lot of overhead and licensing issues as well. And in the past, this has led to many software development shops to limit the number of database servers they build. And they typically have built a development server, which they have a shared database for all developers to connect to and do all their work in the same spot. In addition, in lots of applications, there may be specific database names or specific configuration paths that are required, which means that every time we want to set up a new developer or a new test environment or something else, we need a completely separate database environment from everything else. Again, heavy resource requirements for development and testing, lots of separate machines, a difficult process, which results in just lots of sharing. We try not to go through this process if we don't need to, so we minimize the number of servers. Over the years, licensing has changed, and database software is more efficient. And more importantly, development hardware has become incredibly powerful. It's amazing what modern hardware can do. And because of this, most developers can typically run more than one database in their local workstation. But there are still these challenges of maintaining separate environments, provisioning them, putting them together. This is where operations can help and try to make things easier for everybody else. Now in the past, again, usually we had separate machines for every database environment, which also slows development because it's long lead times to configure and reset these, or to build them up, or to rebuild them. Now, some of our database platforms evolved to allow us to run multiple copies of the database on a single machine, which was helpful. It allowed one machine to simulate multiple servers. But still, the time to create a new environment was cumbersome and large, had to install or reinstall or uninstall software, and so it was problematic. Some people do use multiple instances, like in the SQL Server world, but it's fallen out of favor a little bit for our dev and test world, and it doesn't really fit with our DevOps philosophy. In the last decade or so, virtualization has become a way of simulating multiple computers in one machine, and it's become incredibly popular. This is one way where you can easily provide new development environments to your developers. They can run virtualization on their own machine, so they can have one or more VMs that they run. They can be on a shared server, so I have different VMs for each developer or for each project or each branch. In addition, starting and stopping VMs or resetting a VM from a snapshot is quick and easy. It allows us to provision CI, test environments, development environments separately for the entire machine. We can have a single powerful development server that can now host multiple test systems that we start and stop and reset as needed. This works very well, and many development shops actually use virtualization to amplify their resources, and they promote independent development, independent testing, without requiring the groups to coordinate, schedule time, or avoid conflicts with each other. Virtualization is a great way to ensure that we can stop, start, reset development environments quickly in a DevOps fashion, as needed. We allow the developers the flexibility to experiment with their code, to try things, to abandon environments that are no longer needed and create new ones instantly, refresh them from version control, and get going. The overhead of now requesting a new database environment becomes extremely low with virtualization, and it's become very popular. This also allows us the ability to use and test multiple different versions of a platform. So I can have a SQL Server 2014 and 2016 and 2012 database all on one machine. While virtualization has worked great, in the last few years, computing has continued to evolve, and our software systems have gotten better. We've found ways to even lower the overhead much smaller than running multiple operating systems on a single machine with virtualization. We've added containers. Containers are essentially a process, like a database server, that runs independently of the host system but shares the kernel. So it's much lower overhead than VM. It starts much quicker, it's much less resource intensive, and since each VM runs its own kernel, it needs a complete set of the operating system, so a complete set of files. A container doesn't need that. Containers have certainly started to become popular in dev test environments. If you're in a Microsoft Windows platform, it's built into Windows 10 and Windows Server 2016. And we've extended that to the database. There are now containers that can run the database platform and start and stop independently. Certainly we have to maintain state, and we may need to store our data files or our data separately from the container, but we have the ability to now run containers with database platforms. If you look through the Docker Hub, which is one of the most popular container repositories, we have MongoDB, we have MySQL, and Postgres, and Neo4j, and Redis, SQL Server, and many, many, many other database platforms. These days, almost everything is being built into a container. Now, we still have to deal with that data, so we still have the resource requirements there. And so often what we have to do is configure our containers to connect to those data files outside of the container. So as I start and stop different containers, I still have to maintain that data, which still is its own challenge. But containers have many advantages over separate machines, separate VMs, or instances, not the least of which is that they're much quicker to start and stop or to remap, or to move them around and move around the networking on my local system. Containers also make testing multiple versions of database easier because I can point to the same local host and port and just start and stop containers that have the same mappings for networking, the same mappings for naming, but they have different versions of my database engine. So I can much more easily test different versions of the database against my application code. Now, it doesn't matter what you choose to do. It's a DevOps world and you want to choose what works best in your environment. You can use separate physical machines, you can use virtualization, you can use containers. Doesn't matter. You're going to have similar storage requirements for multiple databases. That will be the same, but you want to choose what works best for you. All of our databases definitely use space, but we can automate so much of the process to ensure that we can easily create environments to provision that data or remove that data, manage our storage, and manage all of our systems to keep our database development flowing as smoothly as possible. There are any number of ways that we can manage our system. Some companies use expensive SAN storage that makes copies. Some companies use copy on write technologies, such as a Redgate SQL clone. Some companies use software that allow multiple databases to share a single copy of the data. It doesn't matter what works. The important thing is for our database development, we want to ensure that we have control and separation. The other thing we want to do is we want to have our virtualization or our containers store different sizes and sets of data, different sizes of databases, so that we can create the environment we need for the appropriate place. Developer may want a smaller environment, test systems may want a medium-sized or the same as developers, and then performance certainly want large systems similar to production. Doesn't matter what solution you choose. As with DevOps, it must be quick and easy and it must work for everybody. I want everybody to understand how we maintain this, how we may change and evolve it over time, and how easy it is to create and use new instances, VMs, containers, whatever you choose. We want it to be an ongoing development task, but one that's quick and easy to ensure that all of our developers use it throughout the entire software development process.